Hello, everyone, and welcome to our webinar on EPA's Phthalate Risk Evaluation under TSCA and our thoughts on the potential implications of these risk evaluations on the plastics industry. We have for you today three extraordinarily gifted professionals from our team. Heather Blankinship is Senior Manager of B&C Consortia Management and manager of several phthalate testing consortia, and also a senior scientist with Bergeson Campbell and the Acta Group. Lara Hall is senior scientist and a quality assurance expert and specialist at B&C, Acta, and B&C Consortia Management. And finally, Dr. Lindsay Holden, a senior toxicologist and regulatory scientist here at Bergeson Campbell and the Acta Group, who joined our team this past summer, and we're so happy for that. I am Lynn Bergeson. I will be your moderator. I am managing partner of Bergeson Campbell and president of the Acta Group. Now, we have far more detailed biographical statements in the resource portal on your dashboard there, along with slides from the presentation, which you should have received already or will be loaded up as we get on with our webinar. We also have prepared for your edification a very, very good resource page or two giving references and other information pertinent to the content of our webinar today. As is our custom, viewers, registrants of this webinar are muted. Our presenters are going to present for about 45-50 minutes. We have a very content-rich webinar for you today. We are then going to pivot to question and answers. Many of you have already asked questions that we are prepared to answer. Questions that we cannot answer due to time constraints will be addressed in writing and will be loaded up to the portal and also sent to our registrants shortly after the webinar. We have an awful lot to cover. Heather's going to kick us off and address regulatory content and the implications to the plastics industry of these risk evaluations. Lindsay is then going to take us through phthalate risk evaluation under TSCA Section 6. Lara is going to cover phthalate testing strategies and test order considerations, which are just hugely important these days. And then Heather's going to take us back and give some pointers, recommendations, and thoughts and conclusory statements. So I'm going to turn it over now to Heather for kicking us off and getting us going. Take it away, Heather.
Thanks, Lynn. To set the stage for our webinar today, I think we should first touch on why phthalates are a focus for risk evaluation and risk management around the globe. As most are aware, there is an ongoing concern about plastics and the environment. There's a significant amount of focus on minimizing and eliminating single-use plastics, recycling, reuse, managing the full life cycle of plastics from raw materials through production and end of life. And this is relevant for phthalates because one of the major uses of phthalates is as a plasticizer. It enhances the performance of other products, making them softer, more flexible, durable, long-lasting. Examples of these uses include coatings, adhesives, and of course, products made from plastics. However, phthalates have several known environmental and human health effects, and phthalates have been detected in the foods we eat as well as measured in humans. So this, in combination with their predominant use in the production of plastics, makes for two strikes against this category of substances. When EPA updated its work plan chemical list in 2014, it cited aquatic toxicity and reproductive and developmental toxicity when it added 7 phthalates into the work plan list. Next slide. Although we're seeing the evaluation and regulation of phthalates across the globe, our webinar today will focus on lessons learned from the risk evaluation of phthalates by EPA under Section 6 of TSCA. To provide some historical context, as EPA completed the risk evaluations of the first 10 substances that were designated as high priority following the passage of the Lautenberg amendments to TSCA in 2016, it began the process of prioritizing what most call the next 20 high priority substances in line for risk evaluation. In December of 2019, EPA designated 20 substances as high priority, 5 of which were phthalates: butylbenzyl phthalate, dibutyl phthalate, dicyclohexyl phthalate, ethyl hexylphthalate and diisobutyl phthalate. The Lautenberg amendments also allow for manufacturers to request that EPA conduct risk evaluations under TSCA Section 6. And so in May of that same year, manufacturers requested that EPA conduct risk evaluations on 2 other phthalates from the work plan chemical list, the isononyl phthalate and diisodecyl phthalate. The manufacturers submitted data to support the risk evaluations and agreed to pay the corresponding fees. And in December of that year, EPA granted those requests for the manufacturer requested risk evaluations, or MRREs as we call them. Next slide. So in 2020, EPA developed and issued the final scopes of the risk evaluations for all of these substances and reviewed reasonably available information for these newly prioritized substances to identify data that could inform the risk evaluations. In 2020 and 2021, B&C Consortia Management assisted several stakeholders in forming 4 consortia, each focused on the risk evaluation advocacy for 4 of the phthalates designated as high priority. In January 2021, EPA began issuing test orders. They started with 9 of the 20 substances. The majority of those test orders were focused on chlorinated solvents that were within that next 20 group of high priority substances, but no test orders at that time for phthalates. Later that year, in July, EPA issued a TSCA Section 8D Health and Safety Data Reporting Rule, and this required manufacturers and importers to submit to EPA all known health and safety data for that next 20 group of high priority substances. Then in May of the next year, 2022, EPA issued more test orders, and we expected at that point that those test orders might focus on some or all of those remaining substances within that next 20 group of high priority substances. But instead, EPA just issued additional test orders for the same substances that it issued test orders for in 2021. It's worth noting at this point that TSCA Section 6 requires risk evaluations to be completed within 3 years of designating those substances as high priority. So, and with the option for a 6-month extension. So for those substances that were designated as high priority in December of 2019, EPA had a statutory deadline of December 2022 or June 2023 if you apply the extension provision to complete those risk evaluations. So at this point, it's not looking too good for EPA as it's still ordering the development of new data in March of 2022 to inform risk evaluations that needed to be completed by June of the following year. In early 2023, at that point, we had not received any test orders for phthalates. So our phthalates consortium met with EPA to discuss potential needs and query whether EPA intended to issue test orders for those substances of interest. EPA told us it would not be issuing test orders for the phthalates, but provided a summary of what it called potentially useful data that would be helpful to inform the risk evaluation. So our consortia reviewed that summary, gathered data where possible, in some instances even generated new data and submitted that information to EPA to support the risk evaluations. I must say at this point, there is no doubt that it has been very challenging for EPA, I'm sure, to try to fill data needs at the same time it's trying to complete risk evaluations, especially with the mandated statutory deadlines. Reflecting on this, I think it seems it would have been more efficient and probably made more sense for EPA to issue the Section 8D reporting rule first to make sure that it obtained and reviewed all existing data before prioritizing any substances for risk evaluation or ordering testing. Next slide. In 2023, EPA was sued for failing to meet its statutory deadlines for issuing final risk evaluations on that next 20 group of substances, and for failing to complete timely the MRREs for the 2 phthalates, DIDP and DINP. The court consolidated those cases, and EPA entered into consent agreements that required it to publish the final MRREs for DIDP and DINP by the end of 2024, and to publish 7 final risk evaluations of the EPA-initiated risk evaluations by the end of this year. So that certainly has been pushing things along. EPA published in final the MRREs for DIDP and DINP in December 2024 and January 2025, and then began issuing the draft risk evaluations for the EPA-initiated phthalate evaluations, beginning with DCHP in January, followed by DEHP and DBP in June, and then BBP and DIBP in August 2025. EPA also issued various technical support documents for each one of those draft risk evaluations, in most cases ahead of the actual draft risk evaluation to allow additional time for stakeholder review. And while this was definitely appreciated, the comment periods for those draft risk evaluations and those technical support documents overlapped, not only between the different risk evaluations, but also with comment periods for the draft charge questions for the Science Advisory Committee on Chemicals that was conducting the peer review of those risk evaluations in August. So this all made it very challenging to prepare and submit comments within the designated comment periods. I should note that the last comment period closed on October the 6th. So BCCM reviewed and prepared and submitted comments in support of its phthalate consortia clients on all of these draft risk evaluations. And so I'm going to turn things over now to my colleague, Lindsay Holden, who reviewed those draft risk evaluations and assisted with preparing those comments. Lindsay?
Thank you, Heather. I will be walking us through 4 main topics: the practical grouping of phthalates as a category, a summary of the draft risk determinations for the high priority phthalates, an overview of how EPA applied cumulative risk in their assessment of phthalates, and a basic rundown of the peer review process to date. Next slide, please. In this tranche of risk evaluations, EPA had 7 phthalates actively under assessment. 2 were manufacturer requested and 5 were designated as high priority chemicals. There's also an 8th phthalate, phthalic anhydride, that is trailing the others, which has a final scoping document available, but has not progressed to a draft risk evaluation. It's reasonable to anticipate that any approaches applied by EPA for the high priority phthalates will also be applied to phthalic anhydride in an upcoming draft risk evaluation. Interestingly, the grouping of phthalates into a category occurred very organically, if I may be allowed a chemistry pun, during the risk evaluation process. The intent of grouping chemicals as a category is that EPA will engage with stakeholders very early in the process, well ahead of prioritization, to assess available data and determine the scientific validity of grouping those chemicals into a category. In this case, these high priority phthalates were initiated as individual chemicals, but grouped together during the risk evaluation process based on time and resource limitations on EPA, as well as due to the similarity across the chemicals. Next slide, please. There are both advantages and challenges to grouping chemicals as a category. First is that it may enable EPA to get through the existing chemicals backlog by providing an opportunity to EPA to do the assessment process one time per category instead of individually per chemical. Within a category, EPA may be able to apply read across, where the advantage is that you don't need to have as large of a body of hazard data if you have appropriate analogs within your category to apply to the individual chemicals. The challenge is that any analog may not faithfully represent the hazard of your individual chemical. Read across may over or underestimate hazard. Another challenge is the sheer volume of material either EPA will need to assess as it approaches a group of chemicals, or in this case with phthalates, 5 individual assessments with upwards of 4,000 pages of technical documentation. Grouping as a category may better support cumulative risk assessment, which is a strong health protective approach to assess exposures to chemicals which behave similarly within a biological system, meaning that they have the same potential health effect. But the challenge is that it requires a consistent approach to hazard exposure and risk assessment, which you'll hear me highlight throughout this section. Next slide, please. As Heather indicated, Phthalates are primarily used as plasticizers. What I would like to highlight is the scale of manufacture, import, production volume. DEHP is at 100 to 250 million pounds per year, whereas the remaining four phthalates vary from less than 1 up to 50 million pounds per year. I'd also like to highlight some of the more novel uses of phthalates, including DBP, which is used in the production of the chemiluminescent light sticks some of us may be cracking out tomorrow as we take the kids out trick-or-treating, as well as DCHP, which is a phlegmatizer used to improve safety and stability of potentially explosive substances. So besides providing the ability to adjust performance characteristics of plastics, phthalates also enrich our lives with fun things like light sticks and improve safety of materials and products. Next slide, please. EPA's risk assessment includes developing technical documents for multiple endpoints, including human health and environmental hazard, as well as exposure to humans and the environment. EPA then takes all that information and develops a draft risk evaluation. The technical documents that are highlighted in blue are those which were developed for all 5 phthalates jointly. Otherwise, EPA developed this whole set of technical documents individually for each phthalate. This is generally performed by EPA with separate teams of experts per chemical. Next slide, please. This summary table provides a very basic overview of the hazard points of departure developed by EPA across the high priority phthalates. In general, the points of departure were based on a developmental toxicity endpoint. For DEHP, this was reproductive tract malformation, and for the other 4 phthalates is fetal testicular testosterone, which falls under the umbrella of phthalate syndrome related effects. Points of departure were based on either no observable adverse effect levels or based on benchmark dose model lower limit of a 5% response by EPA, and then human equivalent values were derived. EPA uses these values to apply to exposure scenarios to understand potential risk. So points of departure are very important for establishing the technical basis for any future rules that may be promulgated by EPA for these phthalates. Next slide, please. I've highlighted some of the high-level comments developed during BCCM consortia efforts, which were submitted to EPA on the health hazard points of departure and exposure assessment on this slide, and we'll talk through each one while we review the next couple of slides. Next slide, please. Our first observation is that the literature and data cutoff was 2019, with very few exceptions. As Heather indicated, there has been an extended timeline for the phthalate risk evaluations, which is a challenge as we're now working with a potential 6-year data gap. Additionally, the fetal testicular testosterone point of departure is based on inconsistent methods across studies, resulting in data not being directly comparable for BMD model approaches. To this end, BCCM Consortia recommended to EPA to use a clear and transparent hierarchy for selection or derivation of the point of departure. Specifically, by starting with the Bayesian benchmark dose modeling, which uses a model averaging approach, and then in this case, considering fetal testicular testosterone as an endpoint is based on 1 standard deviation from the control, which is best practice in this space. Then, if the data are not amenable to modeling, utilizing the no observable adverse effect level, and if a no AL is not available, utilizing the lowest observable adverse effect level. BCCM Consortia also noticed inconsistencies in the model software used by EPA across the phthalates, which complicates direct comparison across chemicals when determining cumulative risk. And there were relevant data that were omitted from benchmark dose modeling that were not substantiated by EPA. So the inconsistent approach and lack of transparency were challenges that we identified across the phthalate risk evaluations. Based on the updated points of departure developed by BCCM consortia efforts, we then derived alternative points of departure based on the best available science that range from 0 to minimal change for EPA's proposed values for DEHP and DBP, which were the two chemicals that had the largest data sets, or DCHP, BBP, and DIBP, for which there was a more sparse data set. We determined the best available science was amenable to BMDL1 standard deviation modeling, which produced points of departure 20% to almost 5 times the points of departure proposed by EPA. EPA then takes these points of departure and human equivalent values to determine occupational exposure values. Next slide, please. In EPA's risk evaluations, they looked at anywhere from 23 to 44 different conditions of use across the phthalates and calculated through standard occupational exposure equations the acute, intermediate, and chronic acceptable exposure values, and determined that there was an unreasonable risk from anywhere from 2 to 24 conditions across the phthalates, mostly in the workplace. Risk was all based on non-cancer hazard from inhalation or dermal exposures. And of note, for DBP, EPA came out with a late-breaking update to their dermal exposure evaluation and updated the underlying science behind their determinations by updating their reliance on guinea pig dermal transport data to human dermal transport data. This removed any risk from dermal exposure and is a great example of application of the best available science. Additionally, EPA applied an aggregate exposure determination for DCHP alone. They did not do this assessment for any of the other phthalates, which is another example of an inconsistent approach across these substances. BCCM Consortia took the proposed alternative points of departure that we developed and calculated out proposed alternative OEVs and provided those to EPA, which are highlighted there in blue. A final point is that we noticed a lack of transparency and consistency across occupational exposure modeling. For example, some of the model parameters, such as dermal exposure in the workplace, are very unrealistic, such as assuming both hands of a worker are fully submerged with no PPE for 8 hours per day. So this is an example of why stakeholder engagement is critical for assessing the appropriateness of EPA's approach during risk evaluation. Next slide, please. EPA also reviewed environmental hazard for phthalates by looking at multiple receptor groups, including aquatic vertebrates, aquatic invertebrates, either in the water column or in the sediment, and aquatic plants and algae. Within these receptor groups, EPA will set a concentration of concern based on the most sensitive group. For DEHP, we see a very low concentration of concern based on a fish, and hazard for other receptors was not determined because of the low solubility of DEHP. DBP has a fairly robust data set where the concentration of concern highlighted in blue in this table is based on aquatic vertebrate values. DCHP, interestingly, had very little data that EPA determined was appropriate for assessing hazard, and EPA chose not to utilize other phthalates for read across. BBP had an adequate data set for determining hazard across receptor groups, and DIBP had a sparse data set similar to DCHP, but in this case, EPA chose to apply read across data using DBP as an analog. I don't have this listed in the table, but EPA also evaluated risk for these chemicals and found an unreasonable risk to the environment across 20 conditions of use for DEHP, 1 to 4 conditions for conditions of use for BBP, DBP, and DIBP, and 0 risk to the environment for DCHP. Next slide, please. EPA completed their own research effort to develop multi-omics points of departure for DBP. They did this in an effort to assess whether or not they could use these points of departure for hazard evaluation. EPA looked at transcriptomics, metabolomics, and behavioral changes, and ultimately decided not to utilize the multi-omics points of departure from that effort. We generally agree with that determination, as this approach needs to be validated before it may be used to establish the technical basis for eventual risk management rules. Through BCCM consortia efforts, we identified data publicly available for DBP that EPA did not consider, or DIBP rather, that EPA did not consider, some of which was submitted to EPA through other TSCA programs, and use those data to calculate the concentration of concern for this substance. So that was at 30 micrograms per liter and is significantly higher than the value that EPA proposed. EPA's approach to environmental hazard is reflective of inconsistent approaches across various phthalates, similar to the human health hazard assessment. In the absence of measured data, there were some model assumptions that were not transparent, including use and waste assumptions by EPA. Next slide, please. As part of this large effort, EPA developed and applied a cumulative risk analysis for phthalates by establishing relative potency factors. To do this, you set an index chemical. In this case, EPA established DBP as the index chemical based on the available body of literature, especially in the low range of concentrations for DBP, then defined a shared health effect endpoint, in this case, fetal testicular testosterone, to derive a relative potency factor for the other phthalates. You may recall that the DEHP point of departure is based on reproductive tract malformations. So DEHP has 2 points of departure, one for the chemical individually and one for use in cumulative risk analysis. As listed in this table, DBP set as the index chemical with an RPF of 1. DCHP has a higher relative potency at 1.6, and the other phthalates have a lower relative potency ranging from 0.21 to 0.84. As part of BCCM consortia efforts, we used our proposed alternative points of departure to calculate proposed alternative RPFs and shared those with EPA. Next slide, please. EPA then describes 2 approaches to evaluate cumulative risk based on a risk cup model. In the risk cup model, you start with an empty cup, and with each exposure, will fill up your cup incrementally. If your cup overflows, then that represents unreasonable risk. To perform this analysis, EPA provided 2 different options for calculating cumulative risk. Option 1, which is represented with the blue color in the images, starts by applying the relative potency factor for each individual phthalate that you are quantifying. And option 2, which is represented with the green color in the images, starts with quantifying each individual phthalate without applying the relative potency factor. For both options, you then add in a cumulative non-attributable exposure to phthalates, which EPA derived using publicly available exposure information, largely based on NHANES surveys to assess the general population baseline cumulative exposure to phthalates. You then add the attributable exposure, quantified via option 1 or 2, to the non-attributable exposure to determine whether or not your risk cup has been overfilled. Interestingly, the 2 options that EPA provides for cumulative risk analysis do not result in the same quantitative outcomes, and there is not clear direction from EPA on when or how to apply each cumulative risk analysis option. This is a very technical topic and requires additional input from EPA on the best way to approach which option should be used by stakeholders. Next slide, please. As part of the risk evaluation process, EPA is statutorily required to put risk evaluations through a peer review process. So in early August, the SAC evaluated 3 of the draft risk evaluations for DBP, DCHP, and DEHP. They reviewed the human health and environmental hazard draft technical support documents for BBP and DIBP, but they did not review risk evaluations for those 2 substances. And they additionally reviewed the 3 cross-phthalate technical support documents for the modeling of fetal testicular testosterone, cancer hazard, and cumulative risk analysis. I don't have time to go in depth on outcomes of the SAC peer review, but the meeting minutes and final report were published on October 6th, and we provide a link in our reference resource. One of the key observations that the SAC made was that they knew that EPA was likely on a short timeline and not going to be able to address all of the concerns that the SAC had identified in their peer review. This is a real challenge with these very tight timelines that EPA is trying to meet while they move through the risk evaluation process, and an indicator that we stakeholders, the community at large, and EPA need additional time to ensure that the best available science is being applied during the risk evaluation and eventual risk management actions. Next slide, please. To wrap up this review of the phthalate risk evaluations, we have a few recommendations. First, EPA should revise their draft risk evaluations for all 5 phthalates, including the technical support and cumulative risk analysis documents, and provide an ample opportunity for public review and comment. EPA should allow peer review for BBP and DIBP draft risk evaluations. As of now, EPA is not planning to have peer review of those documents, although this is statutorily required. EPA should adopt a unified approach across the risk evaluation for all of the phthalates, and moving forward should apply a unified approach for substances within a category. Otherwise, if EPA doesn't apply a consistent approach for assessing hazard, exposure, and risk, then they are not comparing apples to apples, and cumulative risk analysis may become meaningless. Finally, EPA must also clarify how and when to use the individual versus cumulative risk approach, and within that cumulative risk analysis, when to use option 1 versus option 2 to protect workers and the environment. We've covered a lot of information in the last 20 minutes, and so thank you for sticking with me on this very technical portion. And I want to summarize that the key deficiencies in EPA's phthalate risk evaluations are inconsistent and non-transparent evaluation approaches across substances. My colleague Lara will now shine some light on what comes next and how you may want to integrate and apply some of the lessons learned from this phthalate risk evaluation process. Next slide, please.
Thank you, Lindsay. Through the remainder of our presentation, we will look ahead to risk management for phthalates and consider prioritization of other high priority substances for which there may be future data needs and how those might be addressed. As EPA completes its risk evaluations and moves into the risk management phase, we're left reconsidering our product use conditions and patterns, potential environmental and occupational exposures, and facility emissions and releases. This information is necessary to develop strategies to manage any unreasonable risks identified in EPA's final risk evaluations, as well as demonstrate compliance with existing and anticipated discharge limits and chemical exposure limits, or ECHLs. Collection of these data also enables your company to set baselines internally for potential exposures and releases. As for the next substances in EPA sites, EPA has stated that it plans to conduct prioritization annually. EPA continues to use its information collection and testing authorities under sections 4 and 8 of TSCA, less so data collection by subpoena under section 11C. If you can anticipate with high confidence that your subject is subject to substances subject to risk evaluation in, say, the next 5 to 10 years, for example, if your chemical is on the 2014 TSCA work plan, it would be prudent to begin the process of understanding what information you have and devise a strategy to address likely data needs. You may already have existing data readily available from prior regulatory requirements in the US or globally, or perhaps as a matter of due diligence and product stewardship. As new data needs arise, there is a myriad of ways to address them, and the key questions center around when, how, and who will develop the data. Next slide, please. Just as EPA must consider all reliable and reasonably available existing data and best available science, so too must you consider the information already available for substances in your portfolio or supply chain well before any test order is issued. The critical note here is that data are assets. Ideally, companies should be taking stock of existing information prior to and during prioritization, and then engaging during the public process to share that information. Early engagement also can help EPA appropriately articulate and parse the relevant conditions of use. Existing high-quality data on a substance may support a weight of evidence approach for addressing or waiving other endpoints, or may support read-across on data on a similar substance. This is particularly useful in cases where EPA is considering a grouping approach, as done with phthalates. And as Lindsay noted earlier, category designations should happen pre-prioritization, but this process hinges on the availability of reliable and relevant data. In the absence of empirical data, EPA may turn to computational, bioinformatic, and quantitative structure-activity relationship models and high-throughput screening. These predictive tools are only as good, however, as the training data used in validation and model assumptions, and may be limited to substances within a confined domain. It should not come as a surprise that EPA may order testing not only to inform its risk evaluations, but with the added goal of refining the very models that EPA may use in the screening, grouping, and evaluation of other chemicals. Next slide, please. So when testing appears inevitable, what are our options? Do we proceed with a test plan voluntarily, perhaps even proactively, or under duress? At the end of the road, whichever path we take, we are aiming for a reliable data set. The path you choose may be familiar, well-charted course. It may hold unique and unforeseeable challenges. Fortunately, as with any journey, with a roadmap and advanced preparations, there are ways to lessen the burdens of a testing program and avoid common pitfalls. Ongoing data development may be an integral part of your product stewardship plan, or perhaps born out of consultation with EPA, for example, in the early phase of a manufacturer-requested risk evaluation. Regardless of the regulatory context, voluntary testing offers more flexibility and enables companies to budget more effectively the resources and time necessary to strategically navigate a test plan or a monitoring program. The more common inclination, however, is to defer testing until it is mandated, for example, by TSCA Section 4 test orders. In either case, there are key activities leading up to testing that should be considered and addressed to ensure a more efficient program and scientifically meaningful outcomes. Next slide, please. Let's consider for a moment several commonly overlooked aspects of regulatory testing that impact data quality, as well as overall costs and timing. If testing will be contracted with an independent laboratory rather than completed in-house, lab capacity will likely influence study placement. Compliance with good laboratory practice standards, or GLP, is typically required, especially under a test order, which also informs lab selection. A company may prefer to sponsor testing alone or join a testing consortium. Jointly sponsored testing has the primary advantage of pooled resources and precludes any unnecessary duplication of testing. Regardless of the sponsor model employed, program administration and study monitoring will incur additional costs and should be budgeted accordingly. Prerequisite testing is critical to study conduct and ensuring data quality and compliance. Each of these activities can add upwards of $25,000 and together can add several months of lead time prior to definitive testing. For example, documented characterization and stability should be completed before experimental start that is required under GLP standards, and this ensures sample suitability before testing begins. Method development and range finding afford an opportunity to assess the feasibility of the required definitive testing, and it may inform modifications to standard test designs. We suggest incorporating these critical activities in your study plans for transparency and to identify contingencies within the test design and scheduling. This will better inform deadlines set by EPA for ordered testing. A records retention policy is critical to ensuring that study records and specimens, as applicable, are readily retrievable for at least 10 years, as required under TSCA GLPs, or 5 years for testing conducted under TSCA Section 5. This includes documentation regarding manufacture or synthesis, lot-specific characterization, and stability of the substances used in testing. Companies may also be responsible for meeting OSHA record-keeping requirements, which is relevant to occupational exposure monitoring. These data persist beyond the risk evaluation process and possibly well after dissolution of a testing consortium. Archiving, therefore, needs to be a part of your plan. Additional test order requirements may include TSCA fees, consultation with EPA, iterative submissions, methods and endpoints of standard that are outside of standard laboratory practices, and confidential business information considerations. All of these can increase costs upwards of tenfold. Beyond the rigor of GLP requirements and typical prerequisites and regulatory testing, EPA's test orders require additional assurances that the data submitted will be reliable and of sufficient quality to use in EPA's risk evaluations. For example, test orders require that EPA review and approve draft study plans and amendments, and that is prior to GLP required approvals by the sponsor and study director. Test orders now require submission to EPA the test material characterization documentation during the draft study plan review and approval phase. Interim updates to EPA may be required before proceeding to the next study phases. EPA's test orders have shifted to include a tiered testing strategy wherein physicochemical properties and phthalate data may be required and reviewed as a prerequisite to EPA requiring in vitro and in vivo toxicity studies included provisionally in a test order. This phased approach is indeed better aligned with good scientific practices, but it also results in a more iterative review process. And in our experience, that makes for a more protracted path to ordered data. There may be additional study reporting requirements, for example, submission of robust study summaries in the OECD harmonized template format, along with the final study reports that are required. Next slide, please. As EPA estimates the overall process of evaluating existing chemicals through risk management could take approximately 6 years. As Heather mentioned earlier, it's very challenging for EPA to meet its statutory timeline, for example, 3 years from prioritization and designation to completion of risk evaluation, while it awaits and evaluates data developed in a phased approach under a Section 4 test order. The inherent and practical challenges of this approach make EPA's timelines ambitious, to say the least. Identifying quality existing data or developing it earlier in the process, perhaps voluntarily, is far more efficient for all stakeholders than awaiting mandated testing. If a chemical is not designated as a high priority for EPA, you may be thinking, why invest beyond the basic product stewardship and leveraging other global regulatory activities? Engaging in the TSCA process can be very daunting, but the outcome can be worthwhile. It is in the stakeholders' best interest to ensure EPA's assessment reflects reality and is based on sound science. This brings regulatory certainty to your business and can restore consumer and public confidence in a chemical's safety. Organizing and engaging early in the process can optimize your chances for successful and efficient navigation. Industry, rather than EPA, is then in control of when and how resources are allocated to testing, and companies can fulfill their role as sponsor with more autonomy, less bureaucracy, and lower costs. So our advice to you is to anticipate and act now. At this point, I invite Heather to share some closing remarks.
Thanks, Lara. So what's ahead for the plastics industry and consumers? Well, EPA, as we all expect, is reviewing now and preparing responses to public comments on the draft phthalate risk evaluations. We expect EPA to issue final risk evaluations in late 2025 or early 2026. So we should highlight, though, that amid EPA's efforts to complete these 7 risk evaluations by the end of 2025, EPA has also proposed in September to amend its procedural framework rule for conducting risk evaluations. The impact of those changes on the ongoing risk evaluations remains unclear. For example, if the framework rule revisions are finalized before EPA issues in final risk evaluations for phthalates, will EPA revise the draft risk evaluations before issuing them in final? Or if the reverse is true, the final amended risk evaluation framework rule is published after the phthalates are issued, or risk evaluations are issued, will EPA go back and revise them before developing and issuing the risk management rules? We don't know the answers to that right now. But regardless of the timing, stakeholders should be prepared to engage on the proposed risk management rules that are expected in 2027 to ensure the potential that they understand the impacts of potential impacts to their products and their supply chains. It's important to emphasize that even where EPA has identified a condition of use as presenting for contributing to unreasonable risk, there is still room for advocacy during the risk management rulemaking. That a particular company or industry's particular product or process within a condition of use doesn't necessitate regulation. This is particularly true for conditions of use that have been overly genericized in the risk evaluation. EPA will provide public comment periods, likely 45 or 60 days, and we encourage you to familiarize yourself with those final risk evaluations, identify pain points in your operations, understand potential impacts to your business, and be prepared to comment. And don't be surprised if those comment periods for the risk management rules overlap. This is even more reason to do the upfront work to be prepared to comment. Next slide. So what are some things that you can do to get your ducks in a row and be prepared? Establish a baseline understanding of your portfolio and supply chain. Review safety data sheets, product data sheets, query your raw materials suppliers to identify products containing phthalates or manufactured from phthalates that may be at risk for regulation or even possibly bans. Understand your role in the supply chain. Are you a manufacturer? Are you an importer, distributor, user of phthalates? This is going to dictate your potential compliance obligations when risk management rules are issued. Identify and quantify potential exposures. Do you need to do testing or monitoring? If EPA establishes, for example, an existing chemical exposure limit, you'll need to review your workplace to determine what you need to do to meet that limit. Consider exposures across the entire life cycle. Know what you're doing to control those exposures or whether you may need to implement additional controls. This will help you understand if and how you can comply with the eventual requirements of a risk management rule. If you think you may need to consider phasing out or replacing phthalates in your processes or supply chains, be prepared to evaluate those alternatives to understand their risks before you implement them. And I guess I'll just finish by saying that the steps that I've outlined here are really not unique to phthalates. These are all part of a robust product stewardship program that can prepare your business for what lies ahead, whether it's the outcome of these pending phthalates risk evaluations or other substances in the future that may be targeted for prioritization and risk evaluation. Lynn, back to you.
All right. Thank you so much. That was fantastic, Heather, Lara, Lindsay. You shared an awful lot of information, a lot of technical information in a very relatable, clear way. And unsurprisingly, we have like a lot of questions. And as I noted, as is our custom, we will answer as many as we can in the remaining 13 minutes. And those questions that we are unable to address in real time, we will prepare written responses and send written responses to all questions to all of our registrants. We have an exceptionally gifted registrant pool because your questions are really, really good. All right, so here's the first one. EPA previously determined that DINP poses unreasonable risk of injury to human health when workers are exposed to the chemical under 4 conditions of use via inhalation: spray-applied adhesives and sealants, and paints and coatings. EPA mentioned that unreasonable risk is for unprotected workers. Heather, do you see the ruling being extended to protected workers? Do you see any indication that other uses will be considered unreasonable risk?
Well, EPA's inclusion of unprotected workers in its risk determination summary suggests that EPA will require specific workplace controls as part of a workplace chemical protection program to protect workers from exposures that present unreasonable risk. Given the DINP risk evaluation is now final, unless there are new data that suggest the current unreasonable risk determinations should be expanded to other uses, it's unlikely EPA will revise the risk evaluation. EPA does, however, have the authority to revise a risk evaluation, particularly if it needs to do so to address a significant risk that was not covered by the existing risk evaluation.
Okay, great. Thank you. Lara, this one's for you. Applications such as those regulated by the United States Food and Drug Administration are outside the scope of the EPA evaluations. What indirect or direct impacts might the EPA conclusions have on those out of scope FDA related uses, for example, food contact and medical device applications?
Mm. To the extent that FDA is required to use reasonably available information to inform its assessment, I think it's possible that FDA will look at the EPA, what EPA concludes in its risk evaluations, in particular the hazard determinations, and then consider EPA's conclusions and the underlying data and FDA's assessment of the uses for which it has authority. There may also be divestment by manufacturers or offshoring of capability based on future risk management rules, which could disrupt the supply chain.
Okay, great. Lindsay, before you break out those light sticks, here's a question for you. Does epidemiological evidence inform this phthalate risk evaluation?
Yeah, that's a very good question because I talked a lot about animal study data.
Right.
Yeah, so the any available epidemiological data were assessed for all phthalates, but in a lot of those studies, most of the findings were obfuscated by the inherent study design. For example, they may have been a retrospective cohort, so it's really hard to tie cause and effect to those types of studies. Or those studies may have had unquantified co-exposures to other substances. So the EPA used epidemiology studies as supporting information, but all human health effects across the assessed phthalates relied on animal study data. EPA did, however, review NHANES annual biosurveillance data of direct detection of phthalates and their metabolites in serum and I believe in urine across US populations, and use that data to inform the non-attributable value for phthalate exposure. EPA also integrates available occupational monitoring and drinking water data during their risk assessment process.
Okay, great. Thank you. Heather, this next question I think tries to combine several that we received. How might EPA evaluate alternatives as part of any risk management step?
Well, TSCA Section 6 requires that in deciding whether to prohibit or restrict a substance in a manner that substantially prevents a specific condition of use, EPA needs to consider, to the extent practicable, whether technical and economically feasible alternatives that benefit health or the environment compared to the use so proposed to be prohibited or restricted will be reasonably available as a substitute when the proposed prohibition or restriction takes place. So in short, the EPA does consider or evaluate alternatives. In fact, it does an alternative assessment as part of the risk evaluation to inform risk management rulemaking. The key consideration here, I think, is whether the alternatives identified for a condition of use are, in fact, technically and economically feasible. Consistent with our remarks at the end of the presentation, I think if there are potential alternatives for a condition of use of interest for a phthalate or some other substance that may be undergoing risk evaluation, you should be prepared to comment on the technical and economic feasibility of that alternative. In that case, that's influential, in case that is influential in EPA's decision whether to consider banning a particular condition of use. OMB, the Office of Management Budget, the overseer of the rule process, considers alternatives only if they're drop-in replacements. If they require additional development, testing, or modification, then they're not deemed appropriate as an alternative. So it's part of the process.
Yep, great response. Lara, this is for you. You have presented what I regarded as some really valid regulatory and practical reasons why voluntary testing may be worthwhile. Do you see any strategic benefits of deferring testing until EPA issues a TSCA Section 4 test order, aside from just deferring cost?
Thanks, Lynn. Several possible scenarios come to mind. One outcome could be that a test order never comes. EPA or that EPA never asks for the information, and the issue is addressed in the risk evaluation to the client's satisfaction without the need for further data development. Additionally, EPA's own understanding of the information needs is likely to be refined over the course of the risk evaluation process. A test order issued later in the process is likely to be more targeted than industry's or EPA's sense of what it needs earlier on in the process. So I can understand why deferring in that scenario might be an issue. Lastly, it may be that you become aware of a shifting EPA perspective on novel methodologies or fit-for-purpose NAMs. It may make sense to defer testing until questions around those methods have been resolved or a precedent is set for modifications. Conversely, the absence of a validated method may warrant deferring testing. For example, as we've seen with prior test orders, it may be advisable to defer dermal exposure testing due to lack of validated hand wipe methodologies, as identified back in 2021 test orders. And this could be exacerbated by the challenges of substance volatility. So all in all, look at the data you have, look at the data that may be required, and try to put that into the appropriate context of the methods available.
Mm-hmm. Great, thank you. Lindsay, this seems up your alley. You mentioned that EPA is conducting a risk evaluation of phthalic anhydride. How do you expect EPA will use the evaluations it has conducted on those phthalates and or the cumulative risk assessment to inform its evaluation of phthalic anhydride? And finally, do you think EPA will update its cumulative risk assessment to include phthalic anhydride?
So that's a great question, right? It's fun to think about the future and what may happen. There was also a comment or question in while we were talking that phthalic anhydride it's actually a precursor to phthalates. So while I know that EPA has requested some information on phthalic anhydrides in conjunction with requests for other phthalates. So, it will be based on whatever EPA does will be based on the hazards that are determined for phthalic anhydride and whether or not they can be applied within the cumulative risk model based on the mechanism of action. What is that health hazard? Is phthalic anhydride posing the same hazard, the same biological reason as the group of phthalates that we discussed? So if that is the case, then I anticipate that EPA would apply methods, models, assumptions developed during the phthalate risk evaluations directly to an independent phthalic anhydride risk evaluation. And so if there's enough similarities for the chemical structure properties, they may be able to apply read across, but that will just depend on the inherent properties of phthalic anhydride. And whether or not they will update any cumulative risk assessment to include phthalic anhydride, I think again will be determined based on its mechanisms of action, how phthalic anhydride may be presenting a health effect hazard.
Great, thank you for clarifying that. And a couple of questions related to phthalic anhydride and its evaluation as a phthalate. So thank you for that. I'll throw this open to all of you. Maybe Heather, you can get us started. What does the risk management process look like for people involved in supply chain regarding clients that have products that contain phthalates? This registrant is curious about if the current definitions by EPA allow for alternative assessments.
So I think that obviously your ability to conduct an alternative assessment is not restricted here. If you think that you have a phthalate in your supply chain that's critical to your business, you should definitely look at the outcome of the risk evaluations, whether or not EPA is considering your particular condition of use unreasonable risk. And then evaluate whether what alternatives you may have to that, so that you're ready if EPA does decide to go down a path that's too restrictive for you. EPA's phthalates risk evaluations should have information in them about alternatives that EPA has already considered. So you also have that backdrop for purposes of your considerations and perhaps commenting when the public comment period is available for the risk management rule.
All right.
And I would jump
go
in with
ahead.
one last little comment also, is that in that or in the alternatives assessment, it's important to understand your own timelines. So if you're in a heavily regulated industry like the aerospace industry, and there are huge safety considerations that need to be taken into account for development and implementation of any alternatives, that has to go into your cost benefit assessment or when you would want to develop an alternative.
Excellent point, Lindsay. Thank you. Well, thank you. We are at the end of our presentation. I want to direct everyone to all of the wonderful complementary services that Bergeson and Campbell, the Acta Group, and BCCM offer. Please subscribe to our firm alerts. Much of the information that we share today, we share timely and comprehensively to all of our friends and clients. I want to thank Heather, Lara, and Lindsay for just an excellent, excellent webinar. I know I learned a lot, and I hope you all did too. We will be forwarding written responses to all questions, including those we unfortunately were not able to address now. But in the interest of time, we're going to say thank you very much. Happy Halloween, and thanks for joining us today.